Hello, participants, and welcome to the day 5 of this e learning course on chromatography. Really, I am getting energized day by day looking to your suggestions. So, I'll first today take a minute of yours, rather a valuable minute of yours, and I'll just discuss on few of your suggestions and your queries. There was a query in yesterday's, that is day 4 presentation on IEC, that in the one of the question in the test of lanthanum and lutetium, sir, you have not mentioned properly whether it is hydrated or not. It was hydrated. If due to our side error of not mentioning hydrated, if you are losing marks, don't worry, it won't matter. Apart from this, if you have any queries, please let me know. I have received many suggestions and I am working on all. But 4 to 5 suggestions that especially I want to mention over here, of which one suggestion that I am getting over here is, sir, keep on adding animated videos. Friends, whenever and wherever required, I am trying to get animated videos and I am adding it. Second point is, sir, explain more in detail regarding the column, regarding the functioning of each part of the chromatography, different techniques. Also explain how a column is prepared. Friends, all these things will come when we will enter into the advanced phase of chromatography, which is probably going to be arranged in August 2020. Moving further, I have a very good suggestion from some of my students from the state of Gujarat. Friends, my Gujarati students, you are extremely and equally important for me. You are asking me to add Hindi words and Gujarati words. Friends, I will try to do that, but you have to wait a little for that. Try to adjust at least for this phase and do your best. Don't worry about the marks in the test. Don't worry about how will you score, but worry that how will you learn. If you are not getting what I'm speaking in first try, rewind the video and go again. This will help you. This will build the quality of patience in you. A special message to my dear little students of BSc. Other than this, I had another one very good suggestion. Sir, we are waiting for some other courses to start. Friends, as of now, at this very moment, I am announcing that in the next academic year, that is 2020-21, every 2 months, we will be coming up with one such e-learning course, and we promise that the topics will be covered what I have received up till now. That is, as of now, you have suggested me that, sir, come up with spectroscopy. Definitely, I will come with spectroscopy in the coming months. Sir, come up with advanced techniques in chromatography. Definitely, I will come with advanced techniques in chromatography. So, someone has suggested me forensic science. Friends, I am very open when it comes to understanding and knowledge. I have not done much anything in forensic science since my college days up to now, so directly it is not my cup of tea. But I will take a time of 2 to 3 months, and if I can come up with some very good ideas, I'll definitely build a small course on it. Keep flowing on me with your suggestions, with your feedbacks, and even if you find to give me some critics, I'll be happy. I got one very good suggestion in a form of critic. Sir, you are directly uploading the PDF of the PPT. Yes, I am uploading. As of now, this is the moment where I am just providing you with the PDF of the PPT. The suggestion is really good that I should give some additional information in that also. That is very commendable, and I will come on that very soon. I promise that later on, even after the course gets over, when I'll get enough and ample time to compile all the theories, I will prepare a small material, or rather to say a little book on all these things and come up. But as of now, you have to bear with the PDFs. So friends, without wasting any much time, let us begin with our highly anticipated topic of this course, gas chromatography. It is one of the most important tools that industries and the research aspirants across the nation and the globe are using. There are some basic conditions when you are working with gas chromatography. What are these basic conditions? Your sample must be volatile and thermally stable. The mobile phase must be gaseous in nature, and your stationary phase should be such that they must have a property of having high boiling and melting point. This is an indirect way of explaining the stationary phase. By writing boiling and melting, I am suggesting indirectly that stationary phase can be both solid as well as, yes, liquid coated on solid. So, indirect answer to a simple type of a question, that what should be a stationary phase in gas chromatography. Now, when we are defining gas chromatography, we should very well say that it is a technique employed to separate and analyze compounds that can be vaporized without decomposition. When you try to convert your sample into vapor, it should get into vapor and not get decomposed. And when it is passed through the column via interaction with the gaseous mobile phase and the stationary phase. And again, coming to the same point, when you use the word stationary phase, keep in mind that stationary phase can be both a solid and a liquid coated on a solid. Gas chromatography is also popularly identified as vapor phase chromatography. Classifying this gas chromatography. The nature of stationary phase decides the fate of classifying gas chromatography into gas liquid chromatography and gas solid chromatography. So the name itself suggests that gas liquid chromatography and gas solid chromatography, though the mobile phase is constant, it is gas in both the models, whereas the stationary phase keeps on changing, liquid coated in a solid as well as solid. So there are these two types of chromatography functioning in GC, that is gas chromatography. As and when you have learned earlier and you have seen here that it is gas liquid and gas solid, you might have got an idea that the mechanism involved in gas chromatography are also of two types. When you are using GSC, that is gas solid chromatography, it will be adsorption. And when you are using gas liquid chromatography with an star or an into inverted comma liquid coated on solid, it is partition chromatography. So chromatography, being a separation technique, requires some driving force that can isolate compounds from a mixture or a matrix. The two key mechanisms responsible for separation of component in a mixture includes adsorption and partition. So the force of adsorption and the force of partition is the driving force over here that helps the mixture to segregate into different components in the mixture. Correlation between mechanism and application. Separation mechanism, whether adsorption or partition, is majorly governed by the nature of stationary phase. If the nature of your stationary phase is solid, means you are going through a mechanism of adsorption. But assume your stationary phase to be liquid. Mind well, I have put an asterisk over here which suggests that this liquid is not the pure liquid, it is liquid coated on a solid. And when such is the case, that your stationary phase is liquid, friends, it is partition chromatography. So remember these two things, that it is adsorption, it is partition, depending upon the stationary phase that are used over here. Principle of gas chromatography. The basic principle in gas chromatography is that it exploits the difference in partition coefficients of volatile sample between mobile gaseous phase and stationary liquid phase. I am using this word because now we can assume that we are discussing the principle of GLC, gas liquid chromatography, as the sample passes through the column in case of a gas liquid chromatography. In the case of gas solid chromatography, stationary liquid phase with an asterisk suggesting liquid coated on a solid is replaced by solid surface, and hence exploitation of component occur via adsorption. So the principle can be explained in two different manners: gas solid chromatography principle, gas liquid chromatography principle. But the major thing is the exploitation of the components from a mixture either on the base of adsorption or on the base of partition, is the main principle of gas chromatography. In general, gas liquid chromatography is referred to as gas chromatography. Now, here comes a very important indication that even if you have two different types of techniques, that is GSC and GLC, and then also if people say I'm using GC, they generally refer to gas liquid chromatography. It means that gas liquid chromatography must have something very better than gas solid chromatography. So this is the point to be discussed in few slides. Before going to that, a very interesting thing that is coming up is the history of gas chromatography. Gas chromatography was the first analytical instrument associated with computer for analysis, data processing, and result generation. So before this, everything that came was the Michael Sweat story where no instrument was there. First gas chromatograph instrument included a practical where separation of fatty acids using nitrogen gas as a mobile phase was conducted. So here we are knowing now that the mobile phase is dinitrogen gas and the separation of fatty acids will take place. Silicon oil as a stationary phase, from the name itself it suggests it's a liquid coated on a solid, so it will be a partition chromatography. And when it comes to partition, it is GLC. So this is fundamentally the history of gas liquid chromatography. A thermostatic column to maintain the temperature because you are passing a gas, and auto titrating device as detectors, as you did not have those electroanalytical detectors at this time in 50s. Father of gas chromatography. This description that we saw was the first chromatograph instrument which these two stalwarts brought into this world. Archer John Potter Martin is known as the father of gas chromatography, who shared the Nobel in 52 with R.L.M. Singe for inventing partition chromatography. Martin was the first to develop the first gas liquid chromatograph way back in 1952 or even during that period. Two another stalwarts were there in chromatography, and we should not forget them. Erika Kramer and Fritz Piron, theoretical basis of chromatography, or the first prototype of GSC, gas solid chromatography. So, friends, I would rather say in a nutshell that when it came to Martin and Singe, it was a gas liquid chromatography, but when the names Erika Kramer and Fritz Prior are pronounced, always remember of gas solid chromatograph. Very interesting thing that comes up here, mentor Erika Kramer and PhD student Fritz Pryor. This wonderful combination of a mentor and a student, a guide and a student, resulted into the invention of gas solid chromatography. So, in all, when we showcase the history of gas chromatography, apart from the pioneer of the mechanism behind each chromatography, Michael Sweat, these four are to be remembered very well. Erika Kramer, R.L.M. Swinge, Martin, and Fritz Prior. So, friends, remember these names. These are very important names in the history of gas chromatography. A step ahead in the terms of gas chromatography. Liquid chromatography, used in 1930 and early 40s, was grounded with the invention of gas liquid chromatography as the gaseous mobile phase enhanced the diffusion of solutes. The statement itself explains you that when you were using a liquid chromatography, there was a liquid mobile phase, but when you were using a gas liquid chromatography, the mobile phase was gas. And gas mobile phase always overrules the liquid mobile phase as the gas mobile phase can diffuse the solute in a higher amount or in an enhanced form than a liquid mobile phase. So more points for gas mobile phase, a little less points for liquid mobile phase because it was faster, because of the quick diffusion of solutes, it was better, and the separation was very good. So over here, liquid chromatography can be overruled by gas liquid chromatography. Improvisation in gas liquid chromatography. Once you came up with gas liquid chromatography, it was not that old model which is used today, but day by day, year by year, decade by decade, improvisation came. Column, tube packed column with solid support coated with stationary liquid came into existence, and this helped in liquid is coated on the inner surface of the fine tube which is made up of either glass or stainless steel. And now you have an improvised version ranging from tube packed column to capillary columns thin like our hair. Carrier gas. Earlier, when everything started, it was nitrogen, and now you have helium and hydrogen along with flow rate controlling devices. Oven in the older days were vapor jackets or thermostatic blocks, and today you have hot air oven, resistive heating of metal clad ovens. So this is how the things changed, and it helped the new technology that came in oven in the form of resistive heating of metal clad columns helped in extreme and rapid heating and even extreme and rapid cooling, because in gas chromatograph you need to maintain the temperature depending upon your mobile phase and depending upon the sample that is getting vaporized. So temperature maintaining is one of the utmost important point when it comes to gas chromatography, let it be gas liquid chromatography or let it be gas solid chromatography. And this is one of the most important type of oven that can maintain a very faster heating and a very faster cooling technology in our gas chromatograph instrument. Overview of the gas liquid chromatography. Based on the principle of partition coefficient, friends, we are now focusing on GLC, gas liquid chromatography. Based on the principle of partition coefficients, GLC refers as gas, a mobile phase, and liquid with an asterisk, now you know, coated on a solid as a stationary phase. Non-volatile liquid is coated on the inert solid support as a thin layer on the inner walls of the column. Solid support helps to increase the surface area for the liquid to interact with the sample. Liquid layer, low volatility, and high decomposition temperature are the characteristic of the liquid which is going to be coated on the solid in the inner walls of the column and act as a stationary phase. So the solid support used in GSC are glass powder, diatomaceous earths, powdered Teflon, crushed fire bricks, and carbon black. So these are supports. And on this support, you have a liquid which is coated on this solid support as a stationary phase in the form of polyethylene glycol, dimethyl silicon, and diethylene glycol succinate. There might be different possible liquids available, but these three are very popular when it comes to gas liquid chromatography. Overview of a gas solid chromatography. Based on the principle of physical adsorption, GSC refers gas as a mobile phase and solid as a stationary phase. So the solid porous powder as a thin layer along the inner wall of a column is filled as a stationary phase. It can be activated carbon, it can be silica, it can be alumina. So friends, these are the two major slides in the introductory part of gas chromatography, that is overview of the gas liquid chromatography and overview of the gas solid chromatography. The mobile phase is that stagnant, either nitrogen or helium or hydrogen, so you need not to worry regarding the mobile phase much when it comes to gas chromatography, apart from few precautions that are related to use accidents in the laboratory when using gas as a mobile phase. Now, as I told you earlier, that when people say GC, they generally refer to gas liquid chromatography, and now comes the reasons why GLC is more advantageous than GSC. It has a shorter time analysis, better resolution between the peaks. So the two peaks are very well separated in GLC more than GSC. Qualitative and quantitative results are much better in GLC compared to GSC because of a higher surface area. Large concentration range of samples can be evaluated in GLC compared to GSC, as you can use a wide variety of liquid coated and solid stationary phases, and a wide range of stationary phases are available, which I spoke just now. Then what are the limitations even then in GC, which is both GLC and GSC? Analyte must be volatile. You cannot use the non-volatile analyte. Second important thing, volatility of organic compound over 500 gram is rare. Means most of your sample should be below 500 gram. And sometimes there are macromolecules which generally are not acceptable that easily by GC. They go with HPLC or they go with gel permutations or such combinations, but they do not fall in gas chromatography. They fall in the earlier category of liquid chromatography, or rather to say the HPLC huge family. High temperature is possible to result into volatility with a concern regarding decomposition. I mean to say that when by mistake, if the temperature goes too high, sometimes there might be an effect on the stationary phase because of this high temperature. So friends, on the comparison between GLC and GSC, GLC is advantageous to GSC, but when you come towards the limitations of GSC or GLC in the form of GC, these are the few limitations that counts very well. Interaction of sample in GC. Interaction of sample in GC is reflected more with the stationary phase than mobile phase. Friends, I have earlier informed you that mobile phase, although interacts with the sample, as of this primary course, basic course is concerned, we will only try to emphasize on the interaction between the stationary phase and the samples. Stationary phase column with different length and internal diameters are used in gas chromatography. Over here, an interesting thing that comes up is the type of columns. There are two types of columns that are used over here. Number one is a packed column and number two is a capillary column. Now packed column are generally little big and length is very limited. But when it comes to capillary column, they are thin, ultra thin, and they are swirled round and round and round in such a way that there can be meters and meters of these column in a compact format. So two types of column, packed column and capillary column. Moving further in this area, columns. They are the heart of gas chromatography. Here you can see over here beta students that the column is a very width in size and less number of rounds are there. So this column having a larger internal diameter, the space inside is too big. These columns are called packed columns and are filled with solid support that is coated with an immobilized liquid stationary phase. But they are larger in size, so it's a packed column. Capillary columns are hollow silica tubes in which inner wall is coated with immobilized liquid stationary phase of varying thickness. Sometimes solid support is not needed additionally because they are hollow silica tubes. So friends, over here you can see tiny thread-like columns. It's an immense number of whorls from 50 to 80 to 120 to 160, and when you open it, it can be meters of meters. And more the length of the stationary phase, you can separate two compounds very well. I will just take a minute by a rational or a ground observed example. Sometimes you require a very length stationary phase to separate two components which are running very close to each other because of their same property. And why you require a length in the stationary phase? You imagine a race. If I ask two runners who are very good to run 100 meter, both might come at the same time. 500 meter, 1000 meter, they might come at the same time. This is what a packed column is. Maximum length of 5 meters. But when I ask the same two runners to go for a marathon, there will be a difference because the length has increased. So for me, in a layman's language, the length of capillary column is somewhat like marathon, and the length of a packed column is somewhat like a single round that an athlete takes in a stadium. So this is the difference. So two samples when going for a marathon race might have more difference and get separated easily in a capillary column than in a simple packed column. So remember this very well. Stationary phase filled in the column plays a role, but even the length of the column plays an excellent role when it comes to gas liquid chromatography. Gas liquid chromatography. Here the mobile phase is a carrier gas. It is nitrogen or helium or hydrogen. Stationary phase are the microscopic layer of liquid on the inner walls of the column. They might be polyethylene glycol, dimethyl silicon, solid support like glass powder, diatomaceous earth, powdered Teflon can be used. And if the column inner wall is made up of silica, you need not to add other solid support. So remember this slide very well. These are the important points when it comes to gas liquid chromatography. Basic principle of gas liquid chromatography. This we have already done once, but let us repeat it. The basic principle in gas liquid chromatography is that it exploits the difference in the partition coefficient of the volatile sample between the mobile gaseous phase and the stationary liquid phase as the sample passes through the column. If the sample mixture from one end of the column is passing to another end of the column, the sample will get separated based on their interaction with the stationary phase. But as I told you, remember very well, it is gas liquid chromatography, and all over the globe in GLC, people today are using capillary column. Capillary column are thin column like hair, and they have a lot number of rounds and rounds and rounds. So remember the new word that has been today correlated with the capillary column, marathon. Moving further along with this in the gas liquid chromatography, understanding the term partition coefficient. Friends, remember very well, the more the partition coefficient, the more the sample is retained in the column. Now, measurement of affinity of the analyte in the stationary phase. Kc, partition coefficient, is equal to Cs divided by Cm. C is the concentration, S is the stationary phase. Again, C is the concentration, M is the mobile phase. Concentration of sample in the stationary phase divided by concentration of sample in the mobile phase. If the sample is more in the mobile phase, Kc will be less. If the sample is more in the stationary phase, Kc will be more. So partition coefficient is high, it means your sample is in the stationary phase. Partition coefficient is low, your sample is in the mobile phase. Partition coefficient is also called over here distribution coefficient. Mathematical interpretation of partition coefficient. Larger Kc values results in extended retention time of analyte. Exactly what I spoke. More the value of Kc, the stationary phase will catch the sample, or in an opposite way, concentration of sample is more in the stationary phase, so it will take more time to go out, and when it takes more time to go out, you can write that the larger KFC values results in the extended retention time of analyte, more and more retention time of a sample. Now, higher value of Kc indicates more time in the column, lower value of Kc indicates less time in the column for an analyte. Resemblance with the retention time. Altering the values of partition coefficient. Are there any probabilities that the partition coefficient values change? It means the sample starts running quickly. If it is running slow, if it is running too much quickly, can you make it run slow? Yes. Column temperature is an important factor, and chemical nature of stationary phase is important factor. If chemical nature of stationary phase is that good as the sample, they will bind. But if you make a decrement in the nature similarity between the stationary phase and the sample, the attraction might become less and the sample might move faster with the mobile phase. So friends, the mathematical interpretation based on the Kc values, that is partition coefficient, and the mathematical formula for partition coefficient are very much important. How analyte performs in the column. This is very important. First, we'll go through the statement, and then we will see this small indicative picture. Highly volatile analyte elute first. When a sample is more volatile, it will not stick with the stationary phase but will move with the mobile phase. Elutes first with the flow of carrier gas and in context to the column temperature. Partition coefficient value is inversely proportional to the volatility of analyte. This is very much important. Partition coefficient value is inversely proportional to the volatility of analyte. We will learn it how. Get back 2 slides. More the partition coefficient, more the sample is in the stationary phase. Over here, if your sample is more in the stationary phase, it is less volatile. But over here, if the sample is more volatile, it will remain in mobile phase. If it remains in mobile phase, it will remain less in stationary phase. And if it remains less in stationary phase, Kc value will be less. And if Kc value is less, it automatically suggests that it is not in the stationary phase, it is in the mobile phase. See over here. Partition coefficient value is inversely proportional to the volatile. So if volatility is more, Kc value is less. Obviously, if volatility is more, it is in the mobile phase, not in the stationary phase, and stationary phase is directly proportional to Kc. So low stationary, low Kc. More volatility is the analyte. It will move out of the column fast, spend less time with the stationary phase, and hence it is inversely proportional. So these 3 or 4 slides where total mathematical separation mechanism of gas chromatography is involved, according to me, are wonderful points from the mathematical point of view to understand a gas liquid chromatograph. Hope you have got these three slides very well. Retention factor K. Retention factor, sometimes called as a capacity factor, is used to describe the migration rate of an analyte onto a column. If you see the formula over here, retention factor K is equal to Tr minus Tm upon Tm. Tr is the retention time of analyte. Tm is the time taken by a gaseous phase to pass through the column. Retention time is the time between sample injection and generation of an analyte P. That is time taken by a sample from one end of the column. Now I will not write like this, one end of the column to another end of the column. Then it will become HPLC. I will write like this, one end of the column to another end of the column. Because over here columns are long, you cannot put them straight, so you make them circles and circles, what you saw in the picture of packed column and capillary column, and then fit them in the oval. So the temperature is maintained inside the column. So over here, Tr is the time taken by or retention time of analyte, and Tm is the time taken or retention time of mobile phase. Higher the value of K, analyte elutes slow. It is very clear. If the value of K is more, sample is in stationary phase. If the sample is in stationary phase, it will go out slowly. Lower the value of K, sample is less in stationary phase, it will go out quickly, so the analyte elutes first. So friends, according to me, when it comes to GC, retention factor K, also known as capacity factor, is a different thing to remember, whereas the partition coefficient Kc is also a different chemistry to remember. So slide 1, slide 2 and slide 3 are one combination, whereas slide 4 is another thing. Context to gas liquid chromatography. Moving further, major parameters that are involved in gas liquid chromatography. Structure of capillary column, carrier gas as a mobile phase, liquid stationary phase, and temperature programming. When I say temperature programming, it will be the function of O1. When I say carrier gas as a mobile phase, something related to mobile phase and the reservoirs, structure of capillary column, that is your stationary phase, and liquid stationary phase present inside the capillary column. So friends, when we reach to this particular point in this particular presentation of gas liquid chromatography, I must say that we are completing the first part, that is the importance of GC, types of GC, and major points involved in gas liquid chromatography. And from here, when we move further, gas liquid chromatography instrumentation starts. So, the equipments associated with gas chromatography are supply of carrier gas, an injector, temperature regulated oven, column, detector, and recorder. Friends, we will go in detail as per the requirement of the basic course in gas chromatography. Let us start with the first instrumentation picture of gas liquid chromatography. This is a gas cylinder with two different measuring valves filled with gas as a mobile phase. Friends, this first valve will always measure the pressure that is inside the cylinder, and this second valve will always measure the pressure that is going out. From here, it will directly reach over here from the side of the injector port. From the top, you are making the sample go inside. This particular point, which is called injector, also has an oven covered on it, because the sample you inject will be liquid, but when it enters the injector, it will first get vaporized. यहाँ पे याद रखिए, remember, in gas chromatography, mobile phase is gas. ऐसा नहीं है कि sample में gas होना चाहिए. Mobile phase is gas. Your sample can be some liquid, but when you enter that sample, if this is a syringe and this point, this gap is the point from where I'll enter this sample. This is the injector port. When I'm entering like this, and when I push it from the top, the sample that starts going in is a sample that is mixed or dissolved in a liquid, but the temperature over here is that much high that your sample gets vaporized. It travels in a vapor form over here. Remember this point very well. Are you getting it? If you have any queries, let me know. When it enters inside, it passes through this column. When it is passing through the column, it is in an oven. Then it enters into the detector, and from detector on the data recorder. When it goes into the detector, it has to be in the gaseous state, and therefore temperature is also required to be maintained inside the detector. So friends, this is a basic instrumentation flow of a gas liquid chromatogram. Carrier gas can be inert gases like helium, nitrogen, and hydrogen. In 90% cases, helium is used as a carrier gas. It is inert and non-reactive. But friends, for better separation, sometimes hydrogen gas is used, but it is avoided due to its explosive nature. Over here, still cylinders with two-stage regulators are used. These are two different stage regulators. Some regulators are manual pressure regulators that came in the older instrument. Nowadays, there are electronic pneumatic pressure controllers available. But as I told you earlier, the first controller of the pressure is for the gas that is filled inside, and second is for the gas that is permitted to move towards the injector and then to the column. Over here, this gas is called a 5,9 gas, and it is 99.999% pure. 5,9 is something trade name. It has few resin traps that can absorb other gases present as impurities and remove hydrocarbon, oxygen, and water vapor present in your original gas as a mobile phase. So if you are passing nitrogen as a carrier gas, you know nitrogen is collected by distillation of air where O2 and N2 get separated. But sometimes there might be little oxygen that get trapped with the nitrogen. So when you are passing this carrier gas through the channel of GC, it is mandatory that oxygen should not go inside. So if you are using this type of resin traps, it will help you to remove oxygen, sometimes water vapor and hydrocarbon that might get mixed with your carrier gas. So remember this point very well. Difficulty faced in gas chromatography, compressibility of carrier gas and its subsequent influence on the separation. Temperature of the column increased with constant inlet pressure. Average flow rate of the mobile phase in the column decreases and viscosity increases. What happens if compressibility of the carrier gas is changed? It will affect the flow rate of the mobile phase in the column, and even the viscosity changes because if flow rate is less, viscosity differs. Decrease the separation speed and efficiency. So it is important that gas should flow at a fixed rate. The flow of gas should be maintained. If not maintained, these are the consequences that a researcher or an industry person has to face. Injectors. Two phenomena occur simultaneously. After passing through the resin trap, purified helium enters the injector, where it acts like the mobile phase. After passing through the resin trap, purified helium enters the injector where it acts like a mobile phase. Sample already loaded onto the injector is directed to be injected into the column. See, remember very well, sample is loaded onto the injector. How can I explain this over here? Sample is coming from the top, mobile phase is coming from the side, so they two will coincide each other and mix and go. So it is something like that. Injector coming from this way, sample coming from this way, they will coincide and move into the columns. Remember this very well. Sample already loaded on the injector is directed to be injected into the column in the vaporized state. It means sample prepared in the form of solution gets vaporized before it enter into the column. The sample that is inside this injection might be in a solution state, but over here the injector itself works at a temperature which has the capacity to vaporize your sample, and hence the sample when enters inside enters in a vaporized form. You can see on column injectors, splitless injectors, and cryogenic focusing injectors are the three different types of injectors. Friends, these are different types of injectors, and as we are going through the basics of gas liquid chromatography, we will just brush up the three injectors and their probability while used in this instrument. Injector, mode of operation, split mode, and splitless split mode. Split mode is an operational method of an injector where high concentrated level of analyte is used. When you want to use a high concentration of analyte, you use split mode. Only a fraction of sample is injected, rest is vented in atmosphere. Why? Because when the concentration of sample is too high, and if you enter a lot much quantity of the sample, the peak might not come in a proper way. So you only require a very little sample. So when your injector is being operated in a split mode, a very little sample goes inside and the rest is thrown because your sample is highly concentrated. But in the splitless split mode, that is the dual mode, even the low concentration level of analyte is there, it operates very well because complete sample is pushed in the column. Now go in a reverse. If my sample is concentrated, I will prefer split mode. If my sample is not much concentrated, I will prefer splitless split mode. I have even written the values of concentration: parts per thousand, parts per billion, and parts per million. So you might understand 10 to the power minus 3 concentration, that is 0.001, 10 to the power minus 6, and 10 to the power minus 9. So this is where you can use split mode as well as splitless split mode in these types of injectors. I am explaining this splitless injectors. Remember very well, we are now focusing on this injector, that is splitless injector. Dual mode. Splitless mode cannot be continued throughout as the peak obtained will be asymmetric. Henceforth, dual mode comes into operation. What are the criteria or what are the impact of using a splitless split mode is written over here. After every 30 to 60 seconds of run, when splitless mode is converted into split mode. So when you are throwing a small sample also, let me explain it in a more fragile way. Over here, high concentrated of level of analyte is there. So you will use a very little sample and it will go through. But its concentration is too high, so it will work. But over here the concentration is low. So you need to spray more amount. So you are constantly spraying, and you are trying to push all the things inside. But here time is up. When you are pushing the sample inside for 30 seconds, it is enough. Then you should stop. When you are filling it with all the samples, it might happen in some cases that the sample will go in and in and in for 30 seconds and then it will get splitted off. So this is the mechanism of operation when you have a split mode and when you have the dual, that is the splitless split mode, where split mode is used for high concentration of sample and splitless split mode is used for low concentration of samples. What about highly volatile injectors like cryogenic focusing injectors? This is required in the case of highly volatile sample. When the sample is too highly volatile, you require some coating that is made on your sample and then it is thrown inside. So this cryogenic focusing injector is required in the case of highly volatile sample which are condensed with nitrogen gas. So nitrogen gas covers your sample. Once the condensed matrix reaches the head of the column, nitrogen is removed. So due to the covering of nitrogen over your sample will not get volatile effect. It will stay there properly. So remember this, in highly volatile injectors, you have cryogenic focusing injectors used when you have highly volatile samples. So split mode and splitless split mode operations in injector and cryogenic focusing injectors. Still moving further, advancement in GC, auto sampler injectors. You remember HPLC, you have seen two types, a manual injector and an auto sampler injector. A similar thing exists over here. Automatic introduction of sample and minimization in labor cost. If you are injecting a sample automatically, you require less labor, better reproduction and time optimization. Friends, when you are injecting a sample inside an instrument, even the pattern of your injecting, even the force of your injection determines the results. Someone is pressing too hard, someone presses too low. This might also show a little bit impact on the instrument. But if I'm using an auto sampler, every time the same thrust, the same operating procedure, minimizing the errors, reaching to the accurate results, precise results. Extreme small quantity and precise handling. So electronic pneumatic controls and robotic auto samplers are the operations of machine for long hours without human interventions. Friends, I have seen people operating gas liquid chromatography for 24 to 36 hours without their interference. They will give all the commands, they will set all the samples and move away. It will do its own work, analyzing 200 to 300 samples without any human interference or intervention. Yes, but the coding of the software should be accurate. So, this is the advancement that has happened in GC with this passage of span of time. Column ovens. Sample of gas chromatography must be converted into and maintained in vapor state throughout the separation process. Throughout the separation process, friends, it means starting from injector up to detector, there should not be any miss where the temperature changes. So these all components should be inside the column oven, that is the separation process. Injector connections, column, detector connections are all inside the column. Range of the oven should be from 40 degree to 400 degree of temperature in Celsius. Thermal control because of rapid heating and rapid cooling using fans. You should make the oven in such a way that it should heat up gradually, systematically and fast. It should cool down even faster so that you can again use at different temperature. Sometimes I am using or analyzing the oven, analyzing the sample in the oven at 300 degree, and then I get a sample at 100 degree. I should have such cooling fans that it should come down quickly so that I can go with the second experiment. So this is the importance of column. Friends, operations of the oven. You can see here the column is inside the oven. Over here will be the injector. Over here will be the detector. Over here will be the computer. As there are very less number of rounds, it is a packed column. But if there would be a more small tiny rounds like our hair, it has to be capillary column. But over here, it is not capillary and it is not packed. We are focusing on operations of oven. If your experiment has to be examined at a single temperature, it is isothermal operation, steady temperature throughout the analysis, early days chromatographs. But now temperature controlled operations are there. You can design an experiment in such a way that you can change the temperature during the experiment depending upon your samples or mixtures. Temperature program chromatograph per the requirements, allowing separation of analytes with marginal difference in vapor pressure. So these are the old days chromatograph where isothermal operations were there. These are the latest chromatographs where you have latest technology to separate even two samples with a very less difference in their vapor pressure. So these are the operational parts of an oven. Gas chromatography columns. Most of the components of gas chromatograph, most important component of the gas chromatograph is the columns. Quality of separation is dependent on the column quality. Here, if you are using a packed column, they are 1 to 5 meter long and 1 to 5 millimeter in diameter. But capillary columns are micro columns like our hair. Stationary phase is the inner walls of the liquid coatings, and they can be, friends, you won't believe, up to 50 to 75 meters. 50 to 75 meters. Henceforth, due to this long run of the column, as I told you earlier, separation becomes efficient with the example of marathon. Here you can see when you are using capillary column, it might be little less visible, sorry for that, but capillary column is written over here, increase the separation efficiency and ability to work at low temperature. Here it is packed column, improper resolution and pressure drop issues might come. When the pipe is small, pressure remains constant, but when the pipe is bigger, pressure might fall. Better separation in same time or same separation in shorter time with 10 times faster results is possible in capillary column compared to packed column. I am repeating this statement. If you are using capillary column in place of these packed columns, better separation in same time or same separation in shorter time with 10 times faster result. If you keep the time same, separation will be excellent. If you keep the separation same, time will decrease in capillary and it will be 10 times faster and better result in capillary compared to packed columns. So today, scientists and researchers around the globe and industries prefer capillary column over packed columns. Type of columns. Columns should be inert, but be careful, they are fragile. It can be made of glass, it can be made up of nickel or copper up to an extent, depending upon the sample. Otherwise, stainless steel is one of the best. So, these stationary phases, material properties include stationary phases like ether or ester as an anchor functional group because of their unreactive and inert properties and the wet column support. On the other hand, the stationary phase material should have few properties like surface energy should be more. If more the surface energy, more is the capacity holding of the sample onto the column surface. Larger surface area for better interaction and they should be good conductor of heat. Sometimes increasing the heat helps in more attraction because of increase in little bit of their few thermodynamic properties. So over here, if the material is good conductor of heat, the column having this material used as a stationary phase will be affected and impacted by the heat of the oven and henceforth its phenomena of interacting with the sample will be affected. Fused silica column, wall coated open tubular column. It's the column made up of silica and the wall is coated with our stationary phase that is generally liquid coated on solid. That material or silica should be chemically invert and henceforth it is used. It is highly flexible and durable. So people sometimes ask why you are replacing glass column or stainless steel column with this fused silica column. Number one, it does not require any other support. Directly you can fill the liquid. So it is liquid directly coated on the walls of the silica, which is the outermost part of this column. Number two, it is flexible. You can turn round and round and round, and it is durable. These are the reasons why these columns are used, apart from other columns like nickel or copper in few extent, stainless steel or glass columns. So friends, these are the different types of columns that are used in gas liquid chromatography. Detectors. Detector is an important as it detects the analyte depending upon the physiochemical properties when it comes out of the column. Among various detectors, I'll be just talking a few over here. As I told you, never I am going to go in details of the detector as per this course is concerned because we are not focusing on detectors, we are focusing on different types of chromatographies. Flame ionized detectors, thermal conductivity detector, electron capture detector and mass spectrometers, that is GCMS. How we are having LCMS, we also have GCMS. Now, choice of the detector depends upon application for which it is being used. Qualitative and quantitative data requirement, chemistry of your sample, and sensitivity are some of the important parameters that are kept in mind while selecting a detector for the analysis of an analyte in a gas liquid chromatography. So, friends, remember very well, these are the parameters which are kept in mind while selecting a detector. So, this was about detectors. Prior, we had columns, we had oven, and even we had something regarding auto samplers. And we know that as it is a gas mobile phase, you require cylinders to fill, so there is no more chemistry or engineering involved in those cylinders apart from the pressure engineering. Friends, now data systems in gas chromatography, that is the computer part. Data system accepts analog signals from the detector and digitalized to record it and separated peaks in the form of chromatogram. What you are receiving, the information from the detector might be in some codes, but your computer converts those codes into graph, and these graphs are called chromatogram. It automatically reports peak, retention time, peak area, etc. And the software displays the result in an automatic manner. Strip chart recorder, electronic reading integrators, and microcomputers. This is way ahead in the gas chromatography area. I mean to say, earlier strip chart recorders were used as data systems way back. If you remember, or if you recall, when the earthquake happens, there are recorders where a small tip like material is there, pen or pencil, and it moves on the paper, and you get the Richter values, Richter scale values of earthquake. Similar was there in the earlier days that you would be getting the graph on the paper with a pen, that are called strip chart recorders. From there, people went to electronic recording integrators, and today you have microcomputers where you can see your graphical patterns in gas chromatography. So, friends, this was the complete instrumentation of gas liquid chromatography. As you all know, gas chromatography is a huge area. As per the first part is concerned, it was gas liquid chromatography. Now, from this point onwards, we will be discussing gas solid chromatography. But we will not continue gas solid chromatography in this same part of the video. Otherwise, it will be too lengthened. We are stopping over here with the last slide, that was the data systems in gas chromatography. And in the next part of this gas chromatography video, we will continue from this point, that is gas solid chromatography. It is a humble request from my side. Go through the videos very carefully. If you find any errors or sometimes slip of tongue, you can please contact me to verify whether it was an error or a slip of tongue. Friends, if required, go twice, thrice through the videos. It will make your basics clear. Again, I want to clear that in phase 1 that is going now and phase 2 that is going to come up, we are only brushing the basics related to each technology, and in the later months to come we'll be going in depth for different instrumentations. So friends, I am stopping here in this video. Best wishes, you go through it carefully once again if required, and in the next part we will continue from here, that is gas solid chromatography. If you have any doubts, just email me so that I can get back to you with the answers. Thank you.